Here in this section we have volumes using cylindrical shells. Shell formula for revolution above a vertical line. The volume of the solid generated by revolving the region between x-axis and the graph of continuous function. So our function is y equal to f of x and f of x greater than equal to 0. L is less than equal to A is less than equal to X, and X is less than equal to B. And this is above a vertical line. X is equal to L. So volume is equal to integral from A to B 2 pi times shell radius times shell height multiplied by dx. I'm going to explain what shell radius and what shell height is when working on examples. Now here we have summary of the shell method. Regardless of the position of axis of revolution, horizontal or vertical, the steps for implementing the shell method are as follows. So number 1, step 1, draw the region and sketch a line segment across it parallel to axis of revolution. Then label the segment's height or length, so that is called shell height. And this is from the axis of revolution, that is shell radius. Step 2, find the limit of integration for the thickness variable. And step 3, integrate the product 2 pi times shell radius times shell height with respect to the thickness variable x or y. So that depends on if we have horizontal or vertical. So x or y to find volume. Example number 1, use the shell method to find the volume of the solid generated by revolving shaded region above the x-axis. So here we have to use shell method to find the volume, and that's one revolving above x-axis. So the volume of a region revolved above the line parallel to x-axis is given by formula V equal to integral A to B 2 pi times shell radius times shell height times dy. Then draw a line segment across the region parallel to axis of revolution. And so what we have here, shell radius is this part. And shell height is this one. And on this part we have interval of integration. So this part here, we have shell radius, and that is distance from x-axis to an indicated y value. So in this case we have this part here, we have y. So the shell height changes for different values of y. And it's dependent on the given function, which is x equal to y squared. So what we have in this case, the shell height is equal to y squared. And the interval of integration, which is this part, is range of y values that make up the shaded region. So y between a, b inclusive. So what we have for this part is between 0 and square root of 8 inclusive. So our volume is equal to integral from 0 to square root of 8, 2 pi times shell radius is this part, and that is y, shell height as this part, and that is x, and our x based on what is given here is equal to y squared. So 2 pi times y squared times dy, and this is equal to 2 pi times integral y cubed. So here we have y times y squared, that is y cubed, times dy, and this is from 0 to square root of 8. That is equal to 2 pi. So here we have to integrate. I first move this constant 2 pi out of integral, and then we can integrate. So what we have to do here, we have y cubed 3 plus 1, so that will be our power. It's y to the 4th power using same number, that is 4 here in denominator. So we're gonna have 2 pi times y to the 4th power divided by 4, and this is from 0 to square root of 8. I simplified here, so 2 divided by 4, here I have 1 over 2 times pi times y to the 4th power, and we have to use 0 and square root of 8 instead for y. So first using square root of 8 instead for y, we have 1 over 2 times pi times square root of 8 to the 4th power minus 1 over 2 times pi times 0 to the 4th power. So what we have here on this part, we have pi times square root of 8 to the 4th, that is equal to 64, then divide by 2. And what we have here on this part is 0 to the 4th power, that is 0. 0 times pi divided by 2, this part is 0. So this one is 0. And the answer for this part is equal to pi times 64 divided by 2. So simplify, 64 divided by 2 is 32. So the final answer is 32 times pi. So the volume of region revolved above the x-axis is 32 times pi. Example number 2, use the shell method to find the volume of solid generated by revolving the shaded region above the y-axis. So the difference between example number 2 and example number 1 is that here on this part, this one revolving about y-axis, but example number 1 was revolving about x-axis. So because of this, here our volume, we're gonna have times dx. So example number 1 was revolving above x-axis. So in that case, we had this part, we had times dy, but here we're gonna have times dx. So volume is equal to integral from a to b two pi times shell radius times shell height times dx. So this is the volume of region revolved above the line parallel to y-axis. And what we have here on this part, so we have to draw a line and segment across the region parallel to the axis of revolution and label segment length, which is our shell height, and distance from the axis of revolution, and that is shell radius. So in this case, this one revolving above y-axis. So based on that, what we have for shell radius is this one in green. So what do you have here? And shell height is this part. So the shell height changes for different values of x. So that depends on what we have here. If I increase this one, for example, to what I have on that part, and instead of having this vertical line, having this one, our shell height changes. So shell height will change to what I have here on this part. Let's just assume that I have this x. And based on that, this is what we have for shell height. And that is dependent on the given function, which is y equal to 3 times the square root of x squared plus 1. So in this case, the shell height is equal to 3 times square root of x squared plus 1. So shell height is y, and y is equal to 3 times square root of x squared plus 1. And interval of integration, that is this part, which is between 0 square root of 35 inclusive. So here we have x between 0 square root of 35. Now finding volume. So volume is equal to integral. This is from 0 to square root of 35. Well, this one is between 0 square root of 35 inclusive. Times 2 pi times shell radius, and that is what we have here on this part, so that is over x, times shell height is y, and y is equal to 3 times square root of x squared plus 1 times dx. Now this is equal to, on this part we have 2 pi times 3, that part is constant, so moving this outside of integral, 2 pi times 3 is 6 pi times integral from 0 to square root of 35 times x times square root of x squared plus 1 times dx. Now, in this case, to find integral, I'm going to use substitution method. So let u equal to x squared plus 1. So what we have here, I use that one, x squared plus 1. And then finding du divided by dx. So that is 2 times x. The next step, we have to find new limits of integration based on what we have here for u. So substitute the lower and upper limits for x into what we have for u. So what we had, our interval is from 0 to square root of 35. I used these two here instead of x, and then find u. So u is equal to 0 squared plus 1 based on what we have here. So that is equal to 1. And then using square root of 35. For x, we have this one here. So u is equal to square root of 35 squared plus 1 square root of 35 squared, that is equal to 35 plus 1 is equal to 36. So now instead of 0 to square root of 35, we have 1 to 36. So our volume is equal to 6 pi times integral 1 to 36 times x times, instead of square root of x squared plus 1, based on what we had here, I used u, so we have square root of u, and then multiply by dx based on what we have here on this part. Find dx, so du divided by dx equal to 2x, dx is equal to du divided by 2x. So this is equal to, we can simplify 6 divided by 2, which is here in denominator. We're going to have 3 pi integral and then here we can simplify, so x divided by x. What's left, we're going to have square root of u times du. So I used power, so here instead of writing square root of u, I have u to the power is 1 over 2. Now integrate using the power rule. So on this part we have u power is 1 over 2. We're going to have power 1 over 2 plus 1, so that is 3 over 2. So this is the power that we're going to have. And use same number in denominator. So here we have u power 3 over 2 divided by 3 over 2. Instead of writing this way, I just move this and using a reciprocal. So here we have, instead of dividing, I multiplied by 2 over 3. So that is how I have this after integration. Now using 1 and 36 instead of u, and find the final answer. So what I did on this part, first simplify, so 3 divided by 3, we're going to have pi times 2, so it's 2 pi, and then using 36 instead for u and 1 instead of u, so we have 36, and power is 3 over 2 minus 1, power is 3 over 2. So using calculator, 36 to the power 3 over 2, that is 216. So we're going to have 2 pi times 216 minus 1, that is equal to 2 pi times 215. So the final answer is equal to 403 times pi. This means the volume of region revolved above the x-axis is 403 times pi. Example, use the Shannon method to find the volume of a solid generated by revolving the regions bounded by the curves and lines above the y-axis. So what is given here on this part, y is equal to 810 minus x squared, and y equal to 9x squared. X is equal to 0 for x greater than or equal to 0. So in this case, volume is equal to integral from a to b, 2 pi times shell radius times shell height times dx. So in this case we have times dx because this part revolving above the y-axis. So first we have to solve 810 minus x squared equal to 9x squared. So based on what is given here on this part, we have these two y. So 810 minus x squared equal to 9x squared. So solve this equation for x to determine where the graphs of y equal to 810 minus x squared and y equal to 9x squared intersect. So we have 810 equal to 10x squared. So simplify, here we have 81 equal to x squared. What that means, our answer here for x we have -9 and +9. So this means the curves intersect when x is -9 and +9. So here on this part we have a graph of region determined by the given curves and line. So we have to draw a line segment across the region parallel to axis of revolution. So in this case, this one was revolving above y-axis. So I draw this one. This vertical line. So based on that, we can have shell height, which is segment length, and distance from the axis of revolution, that is shell radius. So the shell radius is the distance from y-axis to an indicated x value. So our shell radius is what we have here on x, and shell height is that part. So our shell radius is x and shell height is 810 minus 10x squared. And interval of integration is from this point 0 up to this point, which is 9. So based on what we have here we have +9, so it's from 0 to +9 times 2 pi times shell radius is what we have on x. Again, what if we had this line here? So in that case, our x will be this part, and that is shell radius, and this one would be shell height. So let's just assume that we have this vertical line, which is in green color, and then we have shell height, and that is 810 minus 10x squared, based on what we had here on this part, times dx. Now here we have 2 pi, that is constant, so move this outside of integral, and then rewrite this part. And simplify. So here we have x times 810, x times -10 x squared. We can multiply this. We have 810 and here we have +10, so we can factor of 10 and multiply by 2 pi to have 20 pi instead of 2 pi here. So you can write 20 pi integral. Then I have 81 times x minus x cubed times dx. So this is equal to 20 pi. Here we have 81 times x. So here power is 1. Integrate, we're gonna have 1 plus 1 So power will be 2 and then divide by same number, which is 2. So on this part we have 81 x squared divided by 2 minus, here we have x cubed. So power is 3, 3 plus 1, we're going to have 4, and then divide by 4. And this is from 0 to 9. So now plugging in 9 and 0 here for x. So I used 9 here instead of x. I didn't write 0 because 0 squared times 81 divided by 2, that part is 0, and then 0 to the 4th power divided by 4, so that is 0, and 0 times 20 pi, it is 0. So what I have here is 20 pi times 81 divided by 2 multiplied by 9 squared minus 9 to the 4th power divided by 4. So find the answer for this part, that is equal to 20 pi times. So I subtracted what I have here on this part, that is 1640.25, and then multiply by 20 pi, that is 32,805 times pi. So here is the final answer, that is volume of solid, and this is cubic units, so it's the final answer is 32,805 pi cubic units. Example 4, use the shell method to find the volume of solid generated by revolving the region bounded by the curves and lines above the x-axis. So here on this part we have x-axis, and what is given, x is equal to y squared, x equal to negative 6y, y equal to 3, and y is greater than or equal to 0. So what is given, based on that we have this graph. So this one here, this line is for x equal to negative 6y. This one here is x equal to y squared. And finally what we have here is y equal to 3. So this one revolving about x axis, and I have this horizontal line. So we assume that we have this horizontal line here on this part, and based on that we can find shell height and shell radius. So what we have here on this part, based on this black line, the expression that defines the shell radius is y. And what we have here on this part, shell height is bounded to the left by the curve x equal to negative 6y, and bounded to the right by the curve x equal to y squared. So the expression for the distance between the two curves, negative 6y and y squared, or shell height is, so based on these two, what we have here, we're going to have y squared plus 6y. So that is shell height. And finding a limit of integration, y is between 0, and here on top we have y equal to 3. So y is between 0 and 3 inclusive. Now we can find volume. So volume is equal to integral 0 to 3. This is based on what we have here, this one was given that this is revolving above x-axis. So here we have dy, a y between 0, 3, then times 2 pi times shell radius is y times shell height is what we had here on this part. So it's y squared plus 6y times dy. Now I'm going to simplify. So here I multiply. Now I have 2 pi y cubed plus 12 pi y squared Now finding our integral, we have pi. Here we have y cubed, so that is 3 plus 1. We're going to have 4 and divide by 4. So we have y to the 4th power divided by 4. So divided by 4, but here we have this part 2. We can simplify. Instead of writing 2 here, on this part I can write pi y to the 4th power divided by 2. So I simplify that part. Plus, then here on this part we have 2, so 2 plus 1 is 3. We're going to have y cubed divided by 3, but here we have 12, so 12 divided by 3, we will have 4 pi y cubed divided by 1, so I can just write 4 pi y cubed. So I used 3 instead for y, we have pi 3 to the 4th power divided by 2 plus 4 pi times 3 cubed. Here again we have 0, so I don't need to write that part. But if you had a different number, you're going to have subtraction, so subtracting, and then pi 0 to the 4th power divided by 2 plus 4 pi 0 cubed. So I didn't really write that part because this one is 0, so you don't need that one. And then find the answer for what we have here. We have 3 to the 4th power, that is 81, times pi divided by 2 plus 3 cubed times 4 is 108, multiplied by pi. So we're gonna have 297 divided by 2 times pi, or 148.5 times pi. So this is our final answer, and that is volume of region revolved above the x-axis. Example 5. Use the shell method to find the volume of the solid generated by revolving the region bounded by the curves and lines above the x-axis. So what we have here on this part, y is equal to square root of x, y equal to 0, y equal to x minus 12 divided by 11. So I draw this graph, and here we have x equal to y squared. Here is x equal to 11y plus 12. And here on this part we have y equal to 0. So I will explain how I have these. So first we have to solve equations. Y equal to square root of x and y equal to x minus 12 divided by 11 for x. So the first one here, we have x equal to y squared, and in this case x is greater than or equal to 0, and the other one y equal to x minus 12 divided by 11. Use cross product, so we have to isolate x. Here is 11y equal to x minus 12. What that means, x is equal to 11y plus 12. And now based on what we have here, these two x's, solve for y. So using these two equations, solving for y to determine where the graphs intersect. So I'm going to write that here. We have y squared equal to, so this one, equal to this part, 11y plus 12. Solve for y. So here we have y squared minus 11y minus 12 equal to 0. So solving, we're going to have y equal to positive 12 and y equal to negative 1. So this is our graph. And in this case, when y is equal to 12, x is 144. So here I use this one, y equal to 12. And this part, 12 squared, is equal to 144. So our x is 144. Disregard the value y equal to negative 1, and that is because it doesn't lie in this region. So I didn't use y equal to negative 1, but I used y equal to positive 12. Now assume that I have this horizontal line, and based on that, what we have for shell radius as this part. And here we have shell height. The shell height changes for different values of y, and that is the distance between the two functions, x equal to y squared and x equal to 11y plus 12. So the shell height is equal to what we have here, or 11y plus 12 minus y squared. So it's based on what we have here, but I'm just using 11y plus 12 minus y squared as shell height. So for this one, shell height is this, and what we have for shell radius is what we have for y. So finding volume and also interval of integration is this part. So y is between 0, 12 inclusive. So this one revolving about the x-axis, we're gonna have dy. Volume is equal to integral from 0 to 12, based on what we have here for interval of integration. 2 pi times shell radius is y, and then multiply by shell height is 11y plus 12 minus y squared times dy. So here we have this 2 pi is constant. I'm moving that outside of integral. And then multiply this part y times 11y plus 12 minus y squared. So we're going to have 11y squared plus 12y minus y cubed times dy. So this is equal to 2 pi times, find the integral, we have 11. Here we have y squared, so we're going to have y power is 2 plus 1, so that is 3 divided by 3 plus, here on this part we have 12, power is 1, so 1 plus 1, we're going to have 2, so I'm going to write down steps. So I have 12 y squared divided by 2, but here we can simplify. Minus y to the 4th power divided by 4. And this is from 0 to 12. So I'm rewriting it outward, but simplify. So on this part we have 6y squared from 0 to 12. Now using 12 for y, so this is 2 pi times 11, 12 cubed divided by 3 plus 6 times 12 squared minus 12 to the 4th power divided by 4. Then minus using 0 here, for that part we're going to have 0. So what we have here is 2 pi times, the answer for this part is 6,336. Here for that part we have 864, and here is 5,184, and this part is 0. So add, subtract, we're going to have 2016 multiplied by 2 pi. So the final answer is 4,032 times pi. So this means the volume of region revolved above the y-axis is 4,032 times pi.